Properties of indices, that is, exponents. The properties of indices follow directly from expanding them to look at the repeated multiplication that they represent. Don't memorize properties, just work to understand the process by which we find these properties, and if you can't recall what to do, just repeat these steps to confirm the property. We'll use 3 as the base in our examples, but the properties hold for any base. We show that with base A and powers B and C, we'll use the facts that 3 squared is 3 times 3, 3 cubed is 3 times 3 times 3, and 3 to the 5th is 3 times 3 times 3 times 3 times 3. We need to develop all the properties of indices, also known as exponents, so we can discover one of the inverse operations of raising a number to a power, finding the root of a number to that power. That will emerge from the final property that we'll explore. But getting to that property requires understanding the others first. When multiplying numbers with the same base, just add the exponents. So here we have a to the b times a to the c, and that's just going to be a to the b plus c, right? Because we have the same base there, a. So 3 squared times 3 to the cubed is 2 plus 3, 3 to the 5th. 3 times 3 times 3 times 3 times 3 is also equal to 3 times 3, that's the first 2, times the second 3. So that term here, that is what? That's 3 squared, this is 3 cubed, and this equals 3 to the 5th. That shows that 3 squared times 3 cubed is 3 to the 2 plus 3, or 3 to the 5th. When dividing numbers with the same base, subtract the exponent of the denominator from that of the numerator. So if we're dividing a to the b divided by a to the c, that will be a to b minus c. So let's see that in operation. We have 3 cubed over here divided by 3 squared. So that should equal 3 to the 1, or just 3, right? Because 3 minus 2 is 1. So we expand those out. We have 3 times 3 times 3 divided by 3 times 3. We cross out a couple 3's, and we're left with 3. Okay, so that's 3 to the 1st. So 3 cubed divided by 3 squared is 3 to the 3 minus 2. So 3 cubed divided by 3 squared is 3 to the 1. So that checks out. Any base raised to the power of 0 is equal to 1. So a to the 0 is equal to 1. So based on the multiplication rule, let's multiply 3 to the 0 times 3 cubed. That gives us 3 to the 3 plus 0. So we repeat the left side, and 3 plus 0, of course, is just 3. So any number times 1 is equal to itself. So 1 times 3 to the 3 is equal to 3 to the 3 raised to the power of 3. So we're going to replace 1 with 3 to the 0. 3 to the 0 times 3 raised to the 3rd power equals 3 to the 3. Now we compare those two equations, and we see that 3 to the 0 is equal to 1. Now, this is not just true for base 3, it's true for all bases. A negative exponent moves the number from the numerator to the denominator, and vice versa. So, we have a to the negative b, that's equal to 1 over a to the b. And also, a to the b is equal to 1 over a to the minus b. So based on the multiplication rule and the 0 exponent rules, we have 3 to the negative 1 times 3 to the 1. We add those two, and we get 3 to the negative 1 plus 1. We repeat the left side of the equation, and we get 3 to the 0 over here, indicating that 3 to the negative 1 times 3 to the 1 is equal to 1. But any number multiplied by its inverse is 1. So 1 over 3 to the 1 times 3 to the 1 is 1, which means 3 to the negative 1 times 3 to the 1 is also 1. We compare those two equations, and we get 3 to the negative 1 is equal to 1 over 3 to the 1. Summarizing, we have x to the negative 1 is equal to 1 over x. And of course, x cannot equal 0 because 1 over x is undefined.